let's get some practice answering exam questions about reactions. Sodium thiosulfate, Na2S2O3, reacts with 200 centimeter cubed. So immediately we notice it's in centimeter cubed, not decimeter cubed, so that needs a conversion, of hydrochloric acid, HCl, solution. So here we have aqueous because it's in solution, and it has a certain concentration, 0.2 moles per decimeter cubed concentration. And here we have the balanced equation. A, we need to define the term concentration of a solution. We know the triangle concentration is number of moles divided by volume. You can write that as a formula, moles per volume, moles per decimeter cubed. Now we need to calculate the number of moles of HCl that are added to the sodium thiosulfate. So remember that when we have a solution, we have an active ingredient. In this case, it's actually a liquid, hydrochloric acid liquid, but a liquid is also a pure substance, like a solid. So it asks, calculate the number of moles of hydrochloric acid added to the sodium thiosulfate. So remember that when we deal with solution reactions, the substance that is in solution is a mixture. It's not pure. It's an impure substance, a mixture. This hydrochloric acid was made by mixing hydrochloric liquid, concentrated pure hydrochloric acid, with water. And when you mix the two of them, you get dilute hydrochloric acid, HCl aqueous. But only the liquid, the HCl pure, that's inside there can actually react in this equation with the sodium thiosulfate. This water is just a spectator. And so what this question B is asking us is how much active ingredient of HCl, how many moles of actual HCl are there inside that solution? And to answer that, we make use of this triangle. Concentration is number of moles divided by volume. And we want to know the number of moles. So that's number of moles is equal to concentration multiplied by volume. But remember, we need to be careful over here because we have 200 centimeter cubed. But to use this equation correctly, so that we end up with concentration in molar, N must be in mole, of course, and V must be in decimeter cubed, because molar is mole per decimeter cubed. So we first need to convert 200 centimeter cubed to decimeter cubed. Now we can just do it very simply by dividing by 1,000, and that gives us 0.2 decimeter cubed. And then we can substitute into the equation. We are given the concentration 0.2 mole per decimeter cubed. Let's actually put in the units. That's the same thing as molar multiplied by the volume, which is 0.2 decimeter cubed. 0.2 multiplied by 0.2 is equal to 0.04. The decimeter cubes cancel. We're left with moles, which is the unit of number of moles N, so that's not surprising. And there we have the answer to B. Now we need to calculate the volume of sulfur dioxide gas that is formed if the reaction takes place at STP. We know at STP, 1 mole has a volume of 22.4 decimeter cubed. These are equivalent to one another at STP. So let's write the equation out. Sodium thiosulfate reacts with hydrochloric acid to form table salt, sodium chloride, plus sodium plus sulfur dioxide plus water. Now the only parts that are really of interest to us are the sulfur dioxide, because that's what we have to find out. What's the volume? How many decimeter cubed of sulfur dioxide will be formed? And the hydrochloric acid, because we know from our previous reaction, which used these two pieces of information, that we have 0.04 moles of the active ingredient HCl. So we have a given amount, 0.04 moles HCl, and a required amount, how many decimeter cubed sulfur dioxide will be formed from that. So now we need the ratio in which those two chemicals always react. And it needs to be a mole decimeter cubed ratio. Why? Because we're given information about hydrochloric acid in moles, and we're required decimeter cubed sulfur dioxide. Now remember, this is the ratio. This is not yet the question, it's just the ratio. And we know that the molar reaction ratio of this equation is 1 mole is to 2 mole is to 2 mole is to 1 mole is to 1 mole. We see that simply from looking at the big numbers, the coefficients in the balanced equation. So we just need to write that ratio that's in the balanced equation in the format that's going to be helpful in this question, which is how many moles HCl to how many decimeter cubed of SO2. Obviously, 2 moles is the same thing as 2 moles. Now here we are asking ourselves, 1 mole is how many decimeter cubed? And we know that this is at STP, so the answer is 22,4 decimeters cubed. So this is the ratio in which HCl and SO2 react in this particular reaction. Not always, but in this reaction. Every 2 moles of HCl produces 22,4 decimeter cubed at STP of SO2. Now we get to our actual question. Not the ratio, but our question. Because we do not have 2 moles, and we don't know how many decimeter cubed of SO2 we have. We have to find this out. So we ask our question, how many decimeters cubed of SO2 will you get from? Now be careful, don't go write 2 moles HCl. That's the ratio, that's not the question. This is the question, 0,04 moles of HCl. That's what we have in this particular situation. So this is the particular situation. To answer it, we apply the general ratio. In other words, we multiply the information for this particular situation by a unit factor, a conversion factor, which has moles of HCl at the bottom and decimeters cubed of SO2 at the top. And this is now referring to the ratio in which they always react. For this particular reaction, 2 moles of HCl react to produce 22,4 decimeters cubed of SO2. That's at STP, of course. For this particular reaction, that's how they always react at STP. 0.04 multiplied by 22.4 divided by 2 is equal to 0,448 decimeter cubed of sulfur dioxide. And we can round that off to 2 places behind the decimal comma, 0,45 decimeter cubed.